warahmatullahi wabarakatuh, and a very good day to our lecturer, Dr. Zuraini Aisha, and also to everyone who's watching. So today we are going to present our mini project entitled Improve Feature Selection for Breast Cancer Classification. Before this, we name it as Improve Feature Selection for Cancer Classification using Multi-Omics Approach, but we change it to breast cancer classification only because we only focuses on breast cancer dataset. So in this group, we have Fatin, Nadhirah, Sharifah, Ainun, Nabila, and also Ameer, Solihin. So as for introduction, we go first to the introduction. So breast cancer is the most commonly occurring cancer in women, and it is the second leading cause of cancer deaths in women today after lung cancer. This is based on cancer.org. So according to the American Cancer Society, more than 230,000 women will be diagnosed with breast cancer annually in the United States, and more than 39,000 will die from the disease. Having self-precaution awareness may help to reduce the risk of breast cancer and to prevent the disease from being spread. So in this study, deep learning methods are being used to predict breast cancer, whether it is malignant or benign. So the usage of feature selection method is being used to filter and classify the breast cancer with Wisconsin diagnostic dataset, and also to differentiate the most accurate method for breast cancer prediction.
Assalamualaikum. My name is Fatin Nadhirah binti Abdullah and I'm from 3 SCSB. So for our mini project in feature selection for breast cancer classification. Okay, so for the data and feature part, okay, one dataset was considered for this study, which is the breast cancer Wisconsin diagnostics dataset, which can be obtained from UCI machine learning repository and also from Kaggle. Okay, so in this dataset, there are 569 instances with 212 malignant and 357 benign has been diagnosed. Okay, so for the features, this dataset has 10 features, which is the radius, the texture, perimeter, the area, smoothness, compactness, concavity, concave point, symmetry, and fractal dimension. Okay, so for each of these features, it has their own mean, standard error, and the worst has been analyzed in the dataset. And then our dataset, this dataset has no missing value, which we already prove it at the by using WK at our report. So there's no missing value in this dataset. And then this is the figure for correlation matrix between all 10 features with their mean, standard, error, and the worst. So we can see there's a various color in this. So the stronger the color, the stronger the relationship between the features. Okay, next for our mini project in feature selection for breast cancer classification, about the method and result. Okay, first for the filter technique. Okay, briefly, filter technique is a supervised learning method and assess the relevance of features as scored by looking only at the properties of the data. Okay, and the filter technique will sort all the features inside the dataset by using a ranking method, such as ranker in the WK, to produce an excellent and more relevant features. Okay, so after we got the rank from the WK, we can look at the rank. So low scoring features can be omitted from the dataset to increase the accuracy. So for in this study, okay, we choose top 20 features to increase the accuracy, while the other features are omitted. So for this dataset, we omit around 11 features from the dataset. So but in filter technique, there is one condition named a global minimum, which is if we exceed the global minimum, instead of we increase our accuracy, it will cause our accuracy to decrease. So we have to be careful, but to remove the features. Just for example, if we remove more than 11 features, so our accuracy will decrease. Okay. Next, for the classification, we use NEF bias. Okay, so for this study, the original accuracy without the feature selection is around 92.62%, which is under this figure 2. And then next, for the accuracy after we apply feature selection is 93.85%, which is, we can see that by using feature selection we can increase the accuracy of our dataset. So for this ranker method in WEKA, just choose for the attribute evaluator, just choose info gain attribute eval, and then for the search method we have to choose a ranker, so that it can rank all of our features. Okay.
Assalamualaikum, my name is Mohammad Ameer Solihin. Now I will explain about wrapper technique. Wrapper techniques needs one machine learning algorithm and uses its performance as evaluation criteria. This method was tested to see if the accuracy could further be improved from the others method, which are filter and embedded methods. Wrapper method is a searching for a feature which is best suited for the machine learning algorithm and aims to improve the mining performance. Wrapper method was tested by using a subset evaluator, which is to create all possible subsets from the breast cancer sequencing dataset. In WEKA software, wrapper-based method was used classifier subset eval to perform subset evaluator. And the knife-based classification algorithm has been chosen to induce classifiers from the features in each subset. According to knife-based in figure 4, the selected 6 features which are the best features to improve accuracy and classify the instance in the breast cancer sequencing dataset. Based on figure 5, after tested by using knife-based on selected 6 features, achieve the correctly classified instance or an accuracy is 97.01%. This is guaranteed that those 6 features are most effective features from overall 10 features.
Okay, so we go on with the third technique for feature selection, which is embedded technique. So feature selection algorithm briefly is integrated as part of the learning algorithm, and it performs as a part of the model creation process. So the most typical embedded technique is decision tree algorithm. Decision tree algorithm select a feature in each recursive step of the tree growth process and divide the sample set into smaller subsets. So here I'm using classified subset eval is evaluate, in order to acquire wrapper method in embedded method. So random forest classification algorithm is used to activate classifiers of the selected attributes. So based on random forest, it is shown in figure 6 that 7 selected features are the best ones for classification. So I will enlarge the picture here. So this is the result. So the selected attributes is these 7 selected features, which has been classified through classifier subset eval for the select attributes. So the result from classification is 91.0369% based on the figure 7, which shows the list in accuracy among the three methods, among the three techniques, which is among filter and wrapper techniques. So I will enlarge here. So the result from classification is here. For the second time I did this is 91.7399, but the first time when I did in Weka software is 91.0369%. So this is for embedded technique.
So the conclusion for this study, the performance for all three types of feature selection are good to use in breast cancer classification because all of them achieve above 90% accuracy. The best result achieving approximately 90% accuracy was the wrapper-based method, which with 6 features out of overall 10 features from breast cancer Wisconsin diagnostic dataset with feature vector. Filter-based method is the second best result, achieving approximately 93% accuracy in classifying breast cancer. And lastly, embedded-based method is the least accurate in classifying breast cancer among three types of feature selection, which is achieving approximately 91% accuracy after being tested with 7 selected features. So for the feature works, overall the study was successful in achieving an improvement from 3 methods in feature selection for breast cancer Wisconsin diagnostic. So for the first one is wrapper-based method perform well but is what not tested in comparison between small dataset features and larger dataset features. The second one is feature improvement will require further data collection with a larger and smaller dataset feature space. And lastly, further understanding of the causes of breast cancer Wisconsin to improve all three feature selection.
Okay, next for our references. So we use 2 references in this study. So actually we have more than 2 references, but we only include 2 in this poster because the rest of it doesn't fit in this poster. So you can look at our project report to see the rest of the references. Thank you.